If you're preparing for the John Monash entrance exam, you're already aware that scientific reasoning is one of the harder aspects of your exam. It's the newer test from last year, which replaces reading comprehension. And a lot of students and tutoring companies kind of just teach it as if it was reading comprehension, which isn't the best way to go about preparing. Scientific reasoning is not only about interpreting what the question is asking you to do and then answering questions, and it's not only about memorizing facts. If you're only focusing on those two things, you're not going to end up doing very well. In this video, we'll be going through the exact thinking process you need to master this section, as well as go through 5 JMSS-style exam questions, and I'll be breaking them down step by step so you can see exactly how to apply these strategies in your exam. So if you're serious about getting into JMSS, please give me your full attention for the next little while and test yourself on these questions as well. Without any further ado, let's jump right into it. Okay, let's have a look at this question. Now, most students think that they know cell structures, but JMSS really loves to test your ability to carefully compare features of things that you know under pressure. And this is exactly the kind of question where one small misinterpretation or misreading could cost you a really easy mark. So let's just go through this. The top students I have, the first thing they do is they just quickly skim through the different options. So they don't even look at any of the diagram or anything like that. They just jump right into what the question's asking. So from the diagram, which of the following statements is the most correct? Okay, so which of the following statements is the most correct? So what statements are we given? Well, we're given the statement both cells have a nucleus, only the animal cells has a vacuole, only the plant cell has a membrane, both plant cell and animal cell have a cell wall. Looking at this diagram now, we can see that plant cells have a cell wall, while animal cells do not, right? So plant cells have the cell wall here, animal cells don't. So we know that option D clearly cannot be the correct answer. Option C, only the plant cell has a cell membrane. We can see that in the diagram, both plant and animal cells has a membrane. So this is incorrect as well. Only the animal cell has a vacuole. Well, actually the animal cell doesn't have a vacuole. The only vacuole is in this one, right? So this question is effectively just spot the difference. So we know that the final answer is just going to be A. The key thing that you should keep in mind is that most of these questions you can answer with the information given. That's how they've all been designed. However, if you know the context beforehand, you can quickly answer the question as well. You don't have to go through and read explicitly. But just be very careful because misreading the question could cost you very easy marks. So even if you are really sure about what's going on in the question, it'll always be a good idea to double check with the information you're given really quickly. So this question could be done in maybe 20 seconds if you get really good at it and if you can read quickly. Summary, what we're going to do is we're just going to jump right into the question and then we check answers. Okay, so you can use knowledge that you know. Okay, so use previous knowledge, or we can compare from the diagram and then use elimination. Okay, so we can eliminate each one of these answers sequentially, right? So even though this is really basic biology, these questions really are just testing how quickly and accurately you can rule out correct answers without second guessing yourself. Okay, so this is a speed and accuracy question. Okay, and when you start seeing more questions, you'll realize that a lot of these questions follow really similar styles, right? So whether it's a flow diagram question or whether it's a speed and accuracy question, whether it's a definition question, or whether it's a graph question, you'll be able to compartmentalize each style of question into its own little packet and then identify what the most optimal approach is, right? So for these speed and accuracy questions, just knowing the content is the best way to go about it, but then having methods to compare and contrast quickly is the next best thing as well. So that's what that question looks like. Now, before you start this question, I want you to pause and have a quick read of it and then try and answer it yourself before I actually go through the solution with you. Assuming you've done that, let's go through this one together. So here we're given a table and we're asked to effectively, again, doing what top students do, which is just jump right into what the question is. We are asked to find which metal reacts with hydrochloric acid. So it wants to react with hydrochloric acid, but not with water. So we don't want water. So in summary, we just want something that reacts with hydrochloric acid, and then with water, it's no reaction. Now, you can use your chemistry knowledge and think, oh yes, group 1 elements in your periodic table will always react with blah, 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 and do all that stuff. You can do that. It's so easy to do that. However, when you read this and you see this table is formatted really nicely because it tells you exactly what your regions are that have reactions. So let's look at situations that react with HCl. Well, we only have one situation with metal and HCl's. So we have this guy here. We want this segment of our table. Let's look at the next one. We have water. Which one doesn't react with water? So we're looking at this column now, metal and water. It's the no reaction segment. So what's in common between both these regions? Lead. Okay, so the answer here is just going to be lead. And again, you don't have to read the entire context. I didn't even look at any of this, right? I didn't look at any of this because I knew that this table tells me exactly what I need. Right? I can very easily identify, oh, okay, products formed by metal and water, and then this output is going to tell me what it is. Okay, metal, well, doesn't tell me which metal. Look to the left-hand side, tells me what all the metals are. I can just infer this information straight away from the table. So whenever you have a scientific reasoning question, if you want to get it done quickly, even when you're preparing or practicing, I want you to just look at the question and see if you can answer it without having to read that giant slab of context and giant slab of text. Keep that in mind, because that helps you save a lot of time and then builds your pattern recognition. Pattern recognition is the most important part of scientific reasoning. A lot of people, again, just think, oh, scientific reasoning is just slabs of text you infer and analyze. Reading comprehension. Nope. You infer and analyze, but you don't have to read all those giant slabs of texts, right? You don't have to read all the giant slabs of text. And the more you practice without reading those texts, without reading the big word vomit before, the preamble before, the better you're going to get with it. So just keep that in mind. Hopefully that was a good one. So let's jump into question 3. Again, take your own time to read and answer this question. When you're ready, you can unpause me. Done? Cool. Let's go. So here we have basically a table. I call these styles of questions flow diagram questions, which is weird because this isn't a flow diagram. This is very much a table. So you'd probably think it's a table style question where you're looking for things and analyzing, right? However, if you wanted to represent this situation in a bit of a different manner, you could pretty much do it like this. So you can say this question 1 here. Is it yes? Is it no? And then you can break it down into further questions like this. If it's yes, then you have another question, right? So here, this might be question 2. And then here, this might be question 3. You've probably seen diagrams and stuff like this, right? I call them flow diagrams. I don't know what the proper term is. And then you have yes, no to these questions, and then you could keep branching out, right? You may call them tree diagrams or branching diagrams, whatever. But basically, this table is just a really big form or a really weird representation of your flow diagrams. So how do we answer it? Well, let's figure out what's actually going on. So Stephanie knows that her supernova shows hydrogen and helium lines. So it shows hydrogen. Oh, sorry, let me highlight it nicely. So it shows hydrogen and helium lines. However, she believes the helium lines are much stronger than the hydrogen ones. So we have hydrogen and we have helium, but then the helium is much stronger than the hydrogen. Okay, so the helium is much stronger than the hydrogen. Fantastic. Using this, let's go through and figure out what our question is really asking. It's asking us to figure out what type of supernova Stephanie is analyzing. So what are we going to do? Well, does the spectrum contain hydrogen lines? Yes, it does. Okay, cool. We need to go to question 4. Let's jump to question 4. Are helium lines dominant in the spectrum? Well, yes, it says that helium lines are stronger than hydrogen lines. So, yes. What type of thing is it now? Well, it's just a type 2b. So these flow questions are some of the quickest questions you can answer because once you break down the important information, really easy to just use your table or you use a diagram to figure it out. So these flow questions are super straightforward. And again, some people are crazy and they want to memorize all these different ideas and supernovas and things like that, and they want to memorize all these things. It helps to do that. If you just read that line, you can go, ah, yes, this has to be a type 2b. Most people aren't going to have that in the back of their head. So you need to be able to analyze the information you are given. It's not reading comprehension, it's analyzing. Let's move on to question 4. The question here, so this is all, again, one question, right? So we have this giant slab of text, cool. And then we have this graph that is also given in this question. Okay, so it says after 3 weeks, how much has the alcohol concentration decreased in the container with the tight lid? In your own time, you can pause, have a read of the question. I'll find a way to have both parts up at the same time. But yeah, pause, have a read of the question, and see if you can answer it. All right, let's go through this together. So again, going to ignore every single bit of the giant word vomit that was there. That's what I've been saying this whole time. Ignore the word vomit. After 3 weeks, how much has the alcohol concentration decreased in the container with the tight lid? So let's take a look at this together. So we have week 0, week 1, week 3, week 5, week 7. So after 3 weeks, week 1, 0 to 1, that's 1 week. And then week 1 to 3, well, that's 3 weeks in total. So we know that we're looking at this column here. Now, what does the graph show me? Well, it shows me something called standing time. I don't know what standing time is. That's fine. Then it shows me alcohol concentration. All right, cool. Well, initially, I started with my alcohol concentrations all at 0.1. And then here, I change all my alcohol concentrations by quite a lot. Which one is it asking for? Alcohol concentration decrease in the container with the tight lid. Tight lid is green, so it's this bar here. So I'm looking for the change from this guy, 0.1, to around this guy. Right? And it gives me some options. So here, the value is roughly, if I, use my finger or eyeball it, I can say this is, 0.9 is over here. So I can say this is like roughly 0.095 or something along the lines of that. All right, 0.095, or sorry, 0.0095. Okay, something like that, because it's greater than 0.9, but it's not 0.1, right? So I know that this value here is 0.00095. Right? So what's it asking? It's asking for how much the concentration is decreased in the container. Okay, well, 0.1 subtract with 0.095 is 0.005 roughly. So I know that this has to be the right answer. Okay, and I know it can't be 0.09 because that's, here, that's where the orange bar is. That's what the value of the orange bar is. I know it can't be a difference of 0.2. Okay, and I know it can't be a difference of 0.01 because 0.01 would just be jumping down to the orange bar. So I know that it has to be just this bottom answer there. Okay, again, did we need to read this giant slab of text? No, right? This is, again, JMSS-style questions. This is ICAS-style questions. These are the questions that you will get. These styles of questions are the ones that you will get. It will give you all this word vomit, and it's great to know these things. It's great to have this in your head. However, you don't need to read them in your exam. Okay, you don't need to read them in your exam. You can just infer things from the data itself. You can infer things from the data itself. Don't try and overcomplicate it. Just use what you know. Okay, let's go through the last question. Again, when you're ready, unpause me and then we can go through it together. All right, let's jump into this one. So we are given a formula. Okay, here it says G is acceleration of the object, big G is some constant. This is important, the idea of a constant. M is the mass of your planet, and R is the radius of your planet in meters. All right, cool, good to know. So the table below determines the mass and radius of some planets compared to Earth's. Fantastic. So mass compared to Earth, radius compared to Earth. Which planet has the smallest acceleration due to gravity on its surface? Which planet has the smallest acceleration due to, so in this case, it's going to be just the G value, the little G value, due to gravity on its surface, right? So we're just basically asked to calculate what the tiny G value is. And you might be thinking, okay, well, that's quite difficult because, this is big numbers, right? Weird numbers all the way through, right? Big numbers, weird numbers all the way through. You don't have a calculator in your exam. Right, most ICAS practice papers allow you to have a calculator. We don't have a calculator in the John Monash exam, right? Very rarely do they give you a calculator. So we need to be able to calculate these things relatively quickly. How can we do that? Well, instead of having to multiply by 6.67 times 10 to the negative 11, I know that for every single equation that I do, this G value will always be there every single time. So I can just ignore it because it will be a constant scaling of each one of my values. Every single time, it'll just be a constant scaling of each one of my values. So I can just ignore it entirely. Once I do that, once I get rid of this thing, I get a much simpler g is equal to m divided by r squared. And then from here, all I need to do is just do really quick maths, right? So I can compare Earth, Mercury, Venus, and Mars, right? Because those are the other ones I have. Well, I know Earth is just going to be 1 because it's going to be 1 divided by 1 squared, which is just 1. Okay, so that's the value that I'm basing it off of. Venus, I can take a look and I can go 0.86 and then 0.95. 0.86, 0.95 squared. You can calculate that in your own time. You can kind of just guesstimate that this is going to be roughly close to like the high 0.9s. Okay, roughly. So it's going to be relatively close to this one for Venus, right? And then we come to Mercury, which is 0.55, 0.055, 0.38. Sorry, my mic's in the way, so I can't really see it. Squared. And then you can guesstimate this one as well. Okay, so this is Mercury. And the last one we have is Mars. Maybe I shouldn't have, I should have just like gone sequentially like from this instead. That's okay. Last one we have is Mars, which is 0.11 divided by 0.53 squared. Okay, so it's up to you how you go about doing this. These two are going to be relatively close answers just from looking at the numbers that you have. So it is important that you know how to calculate these things quickly. How you go about doing that is just by practicing numerical reasoning and numerical methods and stuff like that. But you can solve this in your own time. I think I ended up getting Mercury as my answer. Okay, so Mercury, I think it was 0.381 when I did it. And albeit I did this like an hour ago, so maybe it's something. This one's like 0.39. Okay, so it's roughly really close to each other, and that makes sense because the numbers are relatively close as well. But when you're doing the calculations, just make sure you are doing your own time. Okay, so what was the learning lesson in this one? Again, learning lesson is you can create your own little tricks and stuff like that when you're actually doing your exam, and you can learn and try and think logically about the situation, right? Science reasoning isn't just about knowing all the content back to front and memorizing things. It's not only about reading comprehension and then like memorizing the things and then answering the question directly. It's about analyzing and understanding the information you're given and then using your own logic to determine the best possible solution as quickly as possible. So yeah, have a look at some science reasoning questions. It's one of the harder topics in the exam to get right. But once you start getting into the groove of things with science reasoning, it makes life so much easier. It makes life so much easier because the science reasoning aspect is the most fun that you will have for the John Monash entrance exam. And if you're having fun for the science reasoning part, you're probably going to be having fun at the school as well. So it's just something to really set yourself up for success in school. So just keep that in mind when you are doing these questions. So hopefully the approaches I took makes science reasoning a whole lot easier. Hopefully that helped. Hopefully me going through some exam questions helped as well. Like I always say, don't like, don't comment, don't sub. Log off and do something else now. See ya.